Imagine looking up at the night sky, and instead of, just vast, indifferent blackness, you see this scattered continent of metal and ice.
Yeah.
Rocks just drifting out there, silently, some so rich they could make Earth's biggest mines look, well, tiny. For decades, that vision, it's been the stuff of science fiction, right? Pure fantasy, really exhilarating stuff.
Absolutely.
But what if that fantasy is, well, rapidly morphing into something real? A concrete economic opportunity, maybe, and perhaps an equally concrete global political challenge.
Yeah.
Welcome to the Deep Dive, where we plunge into these complex topics, the ones sitting right at the intersection of, let's say, engineering audacity, legal innovation, market speculation, maybe even fantasy, and of course, just basic human imagination.
And that is exactly our mission today. We are embarking on a deep dive into asteroid mining. It's a concept that's frankly leaped from abstract speculation, sci-fi stuff, to actionable business plans and even national strategies much, much faster than maybe even its earliest proponents thought possible. So we're going to meticulously trace its journey. It's fascinating, really, from its sort of romantic historical roots in science fiction through the psychology, the sociology that explains why it grabs us, right into the legal and technical landscapes of today, which are constantly evolving. And we'll also tackle some of the persistent myths and, importantly, the controversies around it. Our main goal for you, listening, is to walk away with a really comprehensive understanding of why this idea captures our minds so much, how it's developing literally in real time, and what the big challenges and, frankly, monumental opportunities actually are, without feeling totally overwhelmed by it all.
Absolutely. And along the way, we have dug up some genuinely surprising facts that might just reshape how you think about this entirely. For instance, we'll explore how the real immediate value in space, it might not be shipping glittering gold or platinum back to Earth. It might be something far more fundamental, something common here, sure, but priceless out there.
Well,
water.
That's a big one.
Yeah. And we'll see how seemingly small nations are already stepping up, actually, with pretty remarkable legal creativity to shape the whole framework of this cosmic gold rush that's just starting. So, yeah, prepare for a journey that's hopefully as thought-provoking as it is entertaining. Okay, let's unpack this. So let's start at the beginning. The genesis of the idea, this notion of reaching out beyond Earth, grabbing resources from other celestial bodies. It's not some flash-in-the-pan idea from a tech startup last year, is it?
Not at all. It's really woven deep into, well, human aspiration, you could say. The origins are quite romantic, stretching way back, first appearing in those imaginative tales, early 20th century science fiction. Writers conjuring up visions of moon bases, asteroid outposts, huge industries out in space.
Right, pure imagination back then.
Pure imagination. Then, during the Cold War, things got a bit more strategic, didn't they? Speculation about space stations, resource acquisition. It became part of that whole geopolitical picture. Still mostly imagination, but something definitely shifted, transforming those dreams into something, well, a bit more tangible.
So how did that happen? How did it move from, like you said, sci-fi and theoretical papers to actual business plans?
Yeah, that shift is really one of the most compelling parts of this whole story. It went from abstract speculation to, like you say, actionable business plans, and crucially, into the sights of serious investors and policymakers. The early 2000s, absolutely pivotal.
Okay.
You had this powerful confluence of factors. Dramatic miniaturization of space tech things got smaller, more efficient. Significant ongoing reductions in launch costs, that lowered the barrier to entry massively. And alongside that, a growing sort of commercial space ethos driven by entrepreneurs.
So not just governments anymore.
Exactly. Not just NASA or ESA pursuing science or national pride. This was private ventures looking at space not just to explore, but as a vast, untapped economic zone. Companies like Planetary Resources, founded 2012, and Deep Space Industries, 2013, they suddenly became names people knew in space circles.
And I remember them making a big splash.
Huge splash, publicly announcing these ambitious plans for asteroid prospecting, mining, and it wasn't just talk. They had investment, they had engineering roadmaps. That really put asteroid resources firmly on the map for investors, engineers, and critically policymakers worldwide. It signaled a fundamental shift in how we saw space.
That's a critical point. So it's not just about cool new rockets or robots. It's a fundamental redefinition of our relationship with space, moving from just looking, exploring to, well, utilization. Commerce, actually doing business out there. It's a paradigm shift.
Precisely, from observation to active participation.
And like any new frontier, especially one as big as space, the law has had to, well, try and keep up, hasn't it? There's a foundational document here, absolutely crucial for understanding ownership and access. The 1967 Outer Space Treaty.
Ah, yes, the cornerstone.
Right. It established that critical framework.
Yeah.
No national appropriation. You can't just land on the moon, plant a flag, and say this is ours now.
Yeah.
It enshrines space as the province of all humankind. That treaty is the bedrock, really, the essential context for everything that's happened since in space law and policy.
And this is where the legal landscape gets incredibly intricate and honestly quite ingenious. What's fascinating here is how national legal systems started to interpret and navigate this international treaty. Because while it banned national sovereignty, it didn't explicitly say much about resource extraction by private companies.
The loophole, perhaps?
Well, maybe not a loophole, but certainly an area open to interpretation. And the pivotal policy shift came in 2015 with the U.S. Commercial Space Launch Competitiveness Act. Most people call it the Space Act.
Right, I remember that.
It was groundbreaking
Yeah.
because it legally permitted U.S. citizens, and by that, they meant U.S. companies to extract, use, and own resources they got from space. This was huge.
So not owning the asteroid itself.
Exactly. They carefully avoided conflict with the Outer Space Treaty there, but they granted property rights to the resources physically extracted. That gave these fledgling space resource companies a significant degree of legal certainty. And you absolutely need that to attract the serious long-term money required.
So the U.S. basically said, go get it, and if you manage it, it's yours. And it wasn't just the big players making moves, right? I remember Luxembourg getting involved.
You're absolutely right. That was fascinating. From around 2016 to 2018, nations like Luxembourg, a relatively small country, but very savvy economically, stepped boldly onto the stage. They created their own sophisticated national frameworks, incentives.
Like what?
Well, notably, they set up a dedicated investment program and passed a specific law, basically mirroring the U.S. one, designed to attract and support space resource companies. It wasn't just trying to get a piece of the action, it was a strategic move. Positioning themselves at the forefront of a new high-value industry. Showed remarkable foresight, really, and legal agility.
Legal groundwork is one thing, but you need the tech too, right? You actually have
Yeah.
to get there and get the stuff.
Absolutely critical. The policy is vital, but you need proof it's even possible. And we've got that proof now thanks to some incredibly successful robotic sample return missions. JAXA's Hayabusa 2, just amazing Japanese engineering, reached asteroid Ryugu, collected samples even from below the surface, and brought them back to Earth in December 2020.
Incredible.
And then NASA's OSIRIS-REx mission brought back a really substantial sample from asteroid Bennu in September 2023. These weren't just science wins, they were mission-level proofs of concept. They showed definitively we can navigate precisely to a distant asteroid, we can safely sample it, and we can get that material back home.
Right.
That shifted the whole conversation. It wasn't, can we do this anymore? It became a very practical, okay, how do we scale this? What's next?
And the future of discovery is already underway, isn't it? What about the Psyche mission?
Yes, NASA's Psyche mission. Launched in 2023, scheduled to arrive at its target, a unique metal-rich asteroid, in 2029. Now, this mission is fascinating. Scientifically, it might be the core of an ancient planetesimal.
Wow.
But critically, its results will directly inform the feasibility, the challenges, the potential methods for metal extraction from these kinds of bodies. It's going to provide invaluable data for any future commercial plans focused on metals. You know, if we connect this back to the bigger picture, it really underscores a crucial lesson. Even the grandest dreams, especially ones needing huge amounts of capital and brand new tech, they need a solid, patient financial runway.
Right. Money talks. Or walks.
Exactly. What we've seen in this very young industry are these fascinating financial cycles and hype. Many of those early asteroid mining startups we mentioned, like Planetary Resources, Deep Space Industries, they generated incredible buzz. Visionary leaders, talented teams, lots of initial investment.
Yeah, they were everywhere for a while.
But over time, many either pivoted their focus dramatically, or they got acquired by bigger companies, or just, well, ceased operations before they actually got to the mining part.
So the enthusiasm outpaced the reality.
That's a good way to put it. Capital enthusiasm often vastly outpaces the incredibly long, hard, and expensive engineering timelines needed for deep space stuff. It's a stark reminder of how fragile these capital-intensive space startups can be when they hit the tough realities of R&D, long deployment schedules, and just the sheer scale of the challenge. It's a marathon, not a sprint, and sometimes the sprinters run out of gas, even the well-funded ones.
And linking back to the legal side, here's where it gets really interesting, I think. Seeing how a country can innovate within existing international law, kind of dancing around potential problems like Luxembourg.
Yes, their approach was a masterclass in legal creativity and strategic thinking. Their law was very, very careful. It doesn't claim ownership of celestial bodies themselves that would clash directly with the Outer Space Treaty, as we said. Instead, their law meticulously recognizes and grants ownership of the extracted resources. Subtle, maybe, but incredibly decisive legally.
So it respects the treaty, no claiming territory, but still gives companies what they need.
Precisely. It gives them that vital security, knowing that what they retrieve, what they spend billions going to get, is legally theirs to profit from. It's a prime example of legal entrepreneurship, honestly. Setting a precedent others are now watching very closely. It shows how even smaller players can shape the future of a global frontier through clever legal maneuvering.
It's so clear, though, this whole thing isn't just about tech and law, is it? It's tapping into something much deeper, something in the human spirit. Asteroid mining absolutely taps into that romanticism of the frontier. It's not just a quaint phrase, it's a powerful story we tell ourselves, right? Freedom, opportunity, pushing boundaries.
Definitely. It's a very powerful cultural narrative. And this call of the unknown, it naturally attracts a certain kind of entrepreneurial personality, doesn't it? People ready to stake a claim in uncharted territory, whether it was the American West way back when or the asteroid belt tomorrow.
Yeah. So what are the psychological traits there?
Well, from a psychological perspective, these individuals often show a remarkably high tolerance for risk, almost a craving for it sometimes. They embody something called future discounting, which basically means they're unusually willing to forego short-term guaranteed returns for the possibility of a much larger, much more speculative payoff way down the line.
So jam tomorrow is fine.
Potentially mountains of jam tomorrow, yes. There's a powerful internal calculation going on where future wealth is valued almost as highly as present wealth, which defies conventional economic thinking. And of course, this is usually coupled with a strong, almost unshakable techno-optimism.
Meaning they believe tech will solve everything.
Pretty much. A genuine belief that technological breakthroughs will inevitably overcome any hurdle, no matter how big it looks right now. It really raises an important question for us, doesn't it? Are we as a species just naturally drawn to the next huge challenge, no matter how far off it is, simply because it's unexplored? That drive to explore, expand, and yes, utilize new places, it seems fundamental, maybe even evolutionary.
And then you throw in these absolutely mind-boggling numbers like a $100 trillion asteroid.
Yeah.
That just bypasses rational thought for a lot of people, right?
Yeah.
Straight to the cognitive biases.
Oh, absolutely. These huge headline valuations trigger what psychologists call availability bias. You hear it often enough, it seems more real, more probable than it is. Yeah. And representativeness bias, because it sounds so grand and futuristic, it must be achievable soon. Investors, the public, people tend to overweight that possibility of a massive payoff, while simultaneously, often unconsciously, underestimating the colossal technical difficulty, the huge costs, and the very real market effects that would happen.
Like the price crashing if you suddenly have tons of platinum.
Exactly, those sensational numbers floating around. They can easily encourage herd behavior and funding. Everyone rushes in, wants a piece of the next big thing, often without fully grasping the economics or the sheer engineering scale involved.
It's fascinating. You think about the gold rushes in history, California, the Klondike. There's that primal pull, isn't there? Immense, untapped wealth just waiting. Space is just the newest, grandest version of that same impulse.
Precisely. The ultimate frontier for that age-old human drive. But beyond the individual psychology, these dreams of space resources have really significant collective and societal effects too, effects that will ripple across nations. Governments increasingly see space resources not just as prestige projects, but as critical for strategic supply chain resilience.
How so?
Well, imagine the geopolitical shift if a nation or a group of nations could secure its own rare earth elements or critical metals or even energy directly from space. Suddenly, you're reducing dependence on volatile terrestrial politics and existing, sometimes monopolized, supply chains.
Right, that would be huge.
It adds a whole new, very potent dimension to great power competition. It fuels a powerful kind of economic nationalism. The race for space resources gets tangled up with national identity, economic security, long-term strategic advantage. It's a new playing field.
But that glittering prospect, it also shines a pretty harsh light on potential problems, doesn't it? Like inequality, distribution anxieties.
Absolutely. If extraterrestrial resources do become economically extractable, bringing immense wealth, the critical question immediately becomes, Who gets access? Who profits? Without robust, transparent international agreements on governance, there's a very real, ethically troubling risk.
That the rich get richer.
Essentially, yes, that this vast new wealth could flow disproportionately to a handful of private firms or to the already advanced spacefaring nations, potentially reinforcing, even dramatically worsening, existing global inequities. It's not just an economic challenge, it's a critical ethical one we need to tackle proactively before the first asteroid mine really opens for business. How do we avoid repeating historical extractive injustices? That's the question.
And it could change work itself too, couldn't it? Creating entirely new jobs.
Oh, completely. Think about the job titles of the future, ones that are mostly sci-fi now. Prospectors, sure, but orbital miners, space mechanics, in-space logisticians, asteroid habitat designers, extraterrestrial environmental engineers, orbital manufacturing specialists.
Wow.
These roles would create totally novel labor markets, new skills, new educational paths, and you can easily see sociological effects like the historical gold rushes. Boom towns, maybe not on Earth, but around spaceports, orbital processing facilities, maybe even lunar bases. This could lead to significant labor migration, reshaping demographics, economic clusters, especially in regions that position themselves strategically, like Luxembourg or certain tech-focused U.S. states. The whole fabric of society, how we work, where we live, what skills we value, could be subtly but fundamentally reshaped.
So it really isn't just about what's out there. It's profoundly about how it's going to change us down here. Our societies, economies, international relations, even our sense of who we are as a species venturing out. The implications are just staggering.
They really are, stretching from the individual right up to the global level.
Okay, let's bring the focus back from those huge societal implications to the sort of tangible realities of today. We mentioned the U.S. Space Act, Luxembourg's framework. It's important to grasp these aren't just theoretical documents, right? They're policy and law in action.
Very much so. They were practical, real-world policy shifts. They actively turned what was a purely speculative, almost sci-fi opportunity into a legitimate policy area where companies could actually operate with some confidence and, crucially, attract serious money.
And their impact went beyond just the U.S. and Luxembourg.
Oh, absolutely. Their impact can't be overstated, and it resonated globally. By granting legal certainty for companies to extract and own space resources, these laws essentially forced governments everywhere to start thinking seriously about the nitty-gritty details. Like, how do we license future space operations? How do we define property rights off Earth? What about liability if something goes wrong?
Right, the practical stuff.
Exactly. These laws weren't just reacting to industry, they acted as powerful stimuli. They actively encouraged private investment and pushed nations to develop their own industrial strategies for the space economy. They basically created a competitive landscape where nations started actively carving out their niche, trying to get that first mover advantage. Hashtag 3.2. Missions that shape public imagination and tech readiness.
And alongside the law, we've seen these incredible tech demonstrations. Those sample return missions, Hayabusa 2, OSIRIS-REx, they did way more than collect dust, didn't they? They validated absolutely critical technologies.
Indispensable technologies for any future resource use in space. We're talking incredibly advanced navigation for pinpoint accuracy in deep space. Precision sampling techniques to grab material from tiny, weirdly shaped, low-gravity objects, and the complex, painstaking engineering for safe Earth re-entry with that precious cargo. These weren't just experiments, they were high-stakes engineering demonstrations on an interplanetary scale.
And they capture the public imagination, too.
Massively. Beyond the pure tech achievements, these missions generated incredible public interest. They produced a steady stream of just stunning images, videos, scientific findings, all feeding public and, importantly, investor interest.
Right. Keeps the dream alive.
Exactly. It took the discussion out of theoretical equations and abstract ideas and put it firmly into the realm of demonstrated capability. Tangible progress, you could see. That sustained public engagement is vital for momentum, for funding, for political will on what's going to be a long, expensive road. And looking ahead, Psyche, targeting that metal-rich asteroid, it promises to explicitly feed both our scientific understanding and, almost inevitably, fuel more economic speculation about getting those metals. It keeps pushing the boundaries of what we think is possible.
So if you look at the space resource industry right now, what does it actually look like? What's emerging?
It's a really fascinating sort of nuanced ecosystem. On one hand, you've got a bunch of ambitious new startups. Some are focused purely on prospecting, finding the good stuff. Others are working specifically on tech to make fuel from asteroid water. Then, on the other hand, you have the more conservative, established players. The national space agencies are shifting their focus. Even sovereign wealth funds from some smaller, forward-thinking countries are carefully trying to figure out their role, their stake in this growing market.
And what's the main focus right now? Still digging for gold.
Well, what's particularly fascinating is this discernible shift in focus, a really strong shift, actually. While that grand, long-term vision of bringing platinum or gold back to Earth still exists out there, the near-term returns, the truly viable business cases, they're overwhelmingly expected from services provided in space for in-space use.
So not mining for Earth, but mining to build an off-Earth economy.
Precisely. That's the paradigm shift. Think on-orbit servicing and refueling for satellites, developing fuel depots using asteroid water to resupply missions going deeper into space, advanced robotics for building things in orbit, maybe even manufacturing components using extraterrestrial materials right there.
So infrastructure first.
Exactly. Current market analyses, they forecast sizable growth in the broader space economy, sure, but they also flag high uncertainty about direct asteroid mining for Earth markets anytime soon. It really underscores this more pragmatic, infrastructure-first approach. It's less about the immediate treasure hunt and much more about building the cosmic highway, the gas stations, the service centers that make future treasure hunts or even colonization feasible.
That's a profound point. It really challenges that initial, simple gold rush image, doesn't it? The immediate value might not be the treasure itself, but the essential infrastructure, the cosmic roads and supply lines that make everything else possible later on. A subtle but really critical distinction.
It really is. It's about enabling the future, not just grabbing the immediate perceived prize. Hashtag tag 3.4. Pop culture's mirror.
And it's also incredibly telling just how deeply this idea of asteroid mining has sunk into pop culture, isn't it? It's not just for scientists or investors anymore. It's a regular theme in blockbuster movies, TV shows, video games, news articles.
Absolutely pervasive. And it's often framed in these really stark, dramatic contrasts, isn't it? Either it's this utopian vision, boundless wealth, limitless resources, humanity's glorious expansion, or it's a grim corporate dystopia, powerful, ruthless companies exploiting the cosmos without any thought for ethics, the environment, or the common good.
So what's the significance of that? Does it actually matter what Hollywood thinks?
I think it matters hugely in shaping our collective understanding. This constant media portrayal, it actively amplifies both the hype and the skepticism. It profoundly influences public expectations, what people think is possible, what they think is desirable, and that inevitably feeds directly into policy debates. What people see in movies, the stories they consume, the headlines they read, it can really shape their opinion on whether this is something we should embrace, something dangerous we should avoid, or just a far-fetched dream that'll never happen. It's like a continuous feedback loop between public imagination, scientific reality, and economic ambition. Pop culture both reflects and shapes the narrative. Hashtag tag 4, debunking myths and navigating controversies.
Okay, let's tackle one of the biggest myths head on. The sensational headlines, we've all seen them, right? Articles breathlessly claiming some asteroid, like Psyche maybe, is worth $10,000 quadrillion or some other just unbelievable figure.
Those headlines grab attention, definitely, but they are profoundly misleading and crucially based on really flawed economics. This raises that important question again. How do we, as listeners trying to understand this, separate the good headline, the clickbait, from the actual economic reality?
So what's wrong with their math?
Well, typically what they do is take the estimated total mass of valuable stuff, platinum, gold, whatever they think is in the asteroid, and just multiply it by today's Earth market price per ounce or kilogram.
Sounds simple enough.
Too simple.
Way too simple. What they completely ignore, what they just gloss over, are the astronomical costs of extraction. The energy needed, the complex robotics, the cutting-edge tech, the sheer number of missions just to start getting materials out. Then there's the equally huge cost of transport, bringing that stuff millions of miles back to Earth.
Okay, the logistics are mind-bending.
Mind-bending, and maybe most critically, they completely ignore basic economics. Market saturation. Think about it. If you suddenly dumped quadrillions of dollars worth of platinum onto the global market, way more than currently exists, what happens to the price?
It collapses. Absolutely collapses. It wouldn't just dip, it would plummet, making the whole massive, expensive effort potentially worthless from a market perspective. And that's not even mentioning the immense unsolved technological hurdles that still exist for industrial scale extraction and processing in space. So yeah, the raw material might be there, but the economic viability shown in those headlines, it's pure fantasy right now.
That's such a crucial distinction. And it's a classic example of cognitive bias, isn't it? Playing on our desire for easy riches. It's essential we all understand the real financial, logistical, and market hurdles. It's not like dipping a bucket into a cosmic well of gold.
Not even close. The laws of supply and demand and the physics of space travel are far less forgiving.
Let's swing back to the legal side again, because this is where ideals really clash with ambition. That 1967 Outer Space Treaty. We said it calls space the province of all humankind. That's often interpreted through this powerful idea of the common heritage of mankind principle, right?
That's right. A principle meant to ensure that the benefits, the resources of space, ultimately benefit everyone on Earth, not just a select few who can get there.
But that seems to clash directly with laws like the U.S. Space Act.
And this is precisely where the profound conflict lies. It stirs up significant international debate, raises fundamental ethical questions. National laws, like the U.S. Space Act or Luxembourg's framework, which grant specific ownership rights to resources after they're extracted. They risk sparking serious disputes about equitable access and distribution.
So who gets the benefit?
Exactly. Critics from many nations and many international legal scholars warn of what they explicitly call space colonialism. They argue that if the rules being developed now don't clearly address how the benefits from space mining are shared globally and how environmental stewardship of these pristine bodies will be managed, well, it could just lead to new inequities, a new kind of resource grab by the powerful. If you connect this to the bigger picture, it's this fundamental deep tension between the drive of national economic interests and those shared global values of common heritage. We've seen this tension play out many times in history with Earth's resources, often with, frankly, regrettable results. This debate is far, far from settled and will shape the legal future of space for decades.
Okay, now for one of those really surprising, maybe game-changing facts we hinted at, despite all the hype about quadrillions in platinum, the initial and probably the most economically sensible target for asteroid mining in the foreseeable future, it isn't shipping rare metals back to Earth.
That's absolutely right. The first real gold, the most immediately valuable resource we'll likely get from space, is water, H2O.
Water. But why?
Think about the logistics. Water is incredibly heavy. Launching it from Earth's deep gravity well is astronomically expensive, but it's absolutely essential for human survival and space life support. And crucially, you can easily split it into hydrogen and oxygen.
Rocket fuel.
Exactly, the primary components of highly efficient rocket propellant. So the strategy becomes clear. Extract water from near-Earth asteroids, which are often rich in these volatiles, and you can make propellant and life support supplies directly in space.
Right, in-space resource utilization, ISRU.
ISRU. It dramatically reduces our reliance on those super expensive Earth launches. It lowers overall mission costs for everything, moon bases, Mars missions, and it enables much longer, more sustainable human and robotic missions deeper into space. It's a pragmatic, infrastructure-first approach, enabling future ops over immediate speculative wealth. And recent mission data spectral studies, and especially those physical samples from Hayabusa 2 and OSIRIS-REx, they're invaluable in telling us precisely where water and other useful stuff actually exists. Making this more than just theory, it's becoming near-term engineering reality.
This feels like a crucial aha moment for many listeners, doesn't it? It completely flips the narrative. The real immediate value isn't the obvious shiny stuff. It's the fundamental enabler, the cosmic water cooler and gas station that makes more value possible later. It's about building that cislunar economy, the infrastructure, not just reading the bank for Earth. A subtle but a really powerful shift in thinking.
It's about sustainable presence, not just smash and grab.
But even if the focus shifts pragmatically to water and services, there's still this huge fundamental question hanging over everything, causing political friction. Who actually enforces the rules out there? International enforcement for space law right now is, well, weak, isn't it? And comprehensive, universally agreed upon regimes, they're barely starting to form. It feels a bit like the Wild West.
It does, and that presents a significant growing risk. Without strong multilateral agreements, binding international frameworks covering things like equitable benefit sharing, clear licensing for extraction, robust liability rules for accidents or environmental damage, unilateral moves by nations or companies could very easily create serious geopolitical friction, even outright conflict.
It's like the old seafaring resource races.
Eerily reminiscent, yes. Powerful nations claiming vast ocean resources without much international oversight, often leading to disputes, instability. Space is the ultimate global commons, a shared heritage. A continued lack of clear, universally accepted governance could quickly turn this incredible opportunity into a new arena for friction, competition, maybe even confrontation. The challenge is immense. It demands unprecedented levels of international cooperation, which is, well, historically difficult.
If you listen to many of the leading voices, especially those really embedded in the space tech world, the entrepreneurial side, you hear this prevailing sentiment from the, well, let's call them the optimistic technocrats. Their core belief isn't just hope. It's almost faith that asteroid mining is going to happen. It's inevitable, the next step.
And they lay out a remarkably consistent path forward, a staged logical progression. It starts, they say, with intensive prospecting, find the right targets. Then the crucial focus on in-space utilization, water for fuel, life support, building stuff in space.
So ISRU first.
ISRU first, definitely. Only much later, once that in-space economy is robust, do they see limited, highly targeted extraction for specialized Earth markets, eventually scaling up. They emphasize the rapid advances in robotics, AI, falling launch costs, efficient solar electric propulsion, all combining to make this plausible, maybe even within a few decades. Even scientists at NASA, ESA, while they frame missions scientifically, they openly acknowledge and strategically factor in the huge industrial potential these missions reveal. They see science and enterprise as two sides of the same coin, really. Hashtags, tag 5.2, cautious, skeptical perspectives.
But then on the flip side, you have the more cautious voices, the skeptics. Often economists, policy scholars, maybe some environmental ethicists. They tend to stress the harsh market realities, the historical precedents, rather than just the cool tech possibilities.
Right. Their concerns are very much grounded in hard numbers, economic principles, lessons learned from mining here on Earth. They point forcefully to the incredibly high upfront costs, the persistent legal fuzziness around property rights, the real risk of price collapse if you suddenly flooded the market with space metals, and crucially, they highlight the current undeniable lack of a proven, viable business model for actually returning high-value metals to Earth profitably, consistently.
So what do they think is viable?
These skeptics often argue the real early business cases, the financially sustainable ones that will attract long-term money, are almost certainly in providing that space infrastructure, developing fuel depots, making radiation shielding materials, providing raw materials for orbital construction, all for in-space use, not the grand, speculative dream of shipping ore back home. What's fascinating here is how that economic lens brings this grounded, often sobering reality check to the grand visions. It's less what if and more what's profitable now or very soon, and who actually pays if it goes wrong.
Then you get some really radical takes, don't you? Especially from commons theorists, anti-colonial scholars. Their fundamental point is powerful. Unchecked corporate extraction of space resources without strong global governance risks just repeating the long, ugly history of extractive injustices we've seen on Earth for centuries.
It's a stark warning. They worry about a potential space grab by powerful corporations or rich nations, possibly at the expense of the majority of humanity.
So what's their solution? Just
solution-
don't do it.
Not necessarily don't do it, but do it very differently. Their proposed solutions challenge conventional thinking. They suggest things like international trusts, where profits from space resources are managed collectively for global benefit, not just private gain. Or explicit benefit-sharing mechanisms. Maybe a UN-led licensing system that links extraction rights directly to contributions to global public goods, funding science, climate tech, poverty reduction on Earth. Their goal is to build equity and justice into the system from the very beginning. Recognizing space not as a free-for-all, but as that shared heritage, a common asset for everyone. It's a powerful call to learn from our past mistakes before we make them again on a cosmic scale.
And it's also really important to remember that where you stand often depends on where you sit, right? Your national perspective, your cultural background, it profoundly shapes how you see this whole thing. Take the United States, for example.
Right. In the U.S., the emphasis is very much on fostering entrepreneurship, protecting intellectual property, setting up those pro-market legal frameworks like the Space Act. The narrative is often driven by the private sector, blending that strong techno-optimism with the rugged individualist frontier idea we talked about, celebrating the pioneers, the innovators.
What about Europe? Luxembourg, for instance.
Europe, especially Luxembourg, shows a different, highly strategic approach. It's been an active, state-led investment strategy. Luxembourg didn't just wait for industry, it proactively offered clear laws and national funding to attract space resource companies, framing it as economic modernization, developing a high-value niche for a smaller nation. Smart industrial policy, really.
And Japan, with missions like Hayabusa.
Japan's Hayabusa missions, while technically astounding and huge scientific achievements, are primarily framed in terms of scientific progress and national pride. Public perception there generally leans more towards the science and exploration side rather than immediate commercial exploitation. Though, of course, the technical successes absolutely feed into future industrial possibilities and boost Japan's tech standing.
And then the Global South. Nations maybe without their own space programs yet?
For many in the Global South, this rush for space resources is often viewed with significant suspicion, sometimes trepidation. It gets likened to a new form of extractive colonialism, echoing historical patterns where powerful nations exploited the resources of less powerful ones. So you hear strong, consistent calls from these nations for more inclusive international governance, for transparency, for meaningful technology sharing, to ensure the benefits, not just the risks or environmental burdens, are shared more equitably across all of humanity.
It really does raise that incredibly important question for our global society, doesn't it? Can we actually build a new frontier in space without just repeating the profound mistakes and injustices of the old ones here on Earth? That's a fundamental challenge for diplomacy, for cooperation, for our collective ethical compass as we step off-world.
A huge challenge, and one we need to address now, not later.
Let's revisit those early pioneers again. Planetary resources, deep space industries. They weren't just dreamers. They really did catalyze interest, didn't they? They brought real teams, real investors, serious plans to the table. Made it seem real.
They were absolutely pivotal in that sense, but their journey offers invaluable, sometimes pretty harsh business lessons for this whole emerging industry. Both companies made tangible progress. Planetary resources with small satellite tech for prospecting, DSI with detailed extraction plans.
But they didn't quite make it to mining.
Not in the way they originally envisioned. Over time, both either significantly pivoted their core business, maybe focusing on Earth applications or other space services, or they got absorbed by larger firms before reaching their full asteroid mining goals. This outcome clearly, powerfully showed that persistent mismatch. Investor timelines, often seeking relatively quick returns, just didn't align with the incredibly long, complex, capital-intensive reality of developing actual asteroid mining tech.
So a reality check.
A major reality check. It's a potent illustration of the immense capital, the deep patience, and the sustained effort needed. The market, in those early stages, simply wasn't ready or patient enough to wait potentially decades for the payoff.
But while those early business models maybe stumbled, the science and tech have just been astounding, pushing us closer. JAXA's Hayabusa 2, that was just a monumental achievement, wasn't it? Getting to Ryugu, sampling it, bringing it back in 2020, a round trip to another world.
Incredible feat of engineering, and its impact goes way beyond just science. That sample return provided real, invaluable, direct data on what carbonaceous asteroids are made of. Details on water content, complex organics, structure. That kind of physical data is absolutely critical for figuring out where useful stuff like water might be best found and accessed for ISRU.
So industrial reconnaissance.
Exactly. If you connect it to the bigger picture, it's not just a science win, it's industrial reconnaissance of the highest strategic value, providing the geological survey for future cosmic mines. And similarly, NASA's OSIRIS-REx collecting that big sample from Bennu, returning it in 2023, it went beyond science too. It showcased the precision navigation needed, the clever engineering for sampling on a hazardous surface, the challenge of re-entry. Its success really shifted the discussion from theoretical to demonstrated capability in everyone's mind. Proved we can actually do this.
And looking ahead, NASA's Psyche mission, launched 2023, arriving 2029.
Yeah.
That promises even more insight, especially about those metal asteroids, right? It's going to study this unique metal-rich body, maybe an ancient planetary core.
Exactly. Psyche's role is absolutely crucial for understanding metallic asteroids fundamentally. The data it gathers will let scientists dramatically refine our models of their structure, their composition. That's essential for assessing if large-scale metal extraction, or maybe even processing in situ right there in space, is feasible down the line.
So primarily science, but with huge implications for future industry.
Precisely. It's mainly a mission of scientific discovery, trying to understand how planets form. But its findings will directly feed into the complex engineering, logistical, and economic calculations for any future metallic asteroid mining. It's laying the groundwork, providing the detailed blueprints for an industry that's still decades away, maybe, but one with undeniable potential.
Okay, let's zoom out now. Let's do a critical analysis based on everything we've talked about. Right. Strengths, weaknesses, potential dangers of this whole ambitious idea. What are the big potential benefits?
Well, one of the clearest, most immediate strengths is how asteroid mining, especially for water and volatiles, could profoundly enable much deeper, more sustainable space operations.
Right, the ISRU point again.
Exactly. Imagine water, oxygen, other resources readily available in space. It dramatically cuts our dependence on those incredibly expensive, heavy Earth launches. That alone could pave the way for a truly sustainable human presence beyond Earth. Lower mission costs, vastly expanded capabilities for exploration, habitation,
and economic benefits beyond just space.
Absolutely. For smaller economies like Luxembourg, strategically investing in space resources offers a high-value knowledge economy niche, diversifying beyond traditional industries, becoming leaders in a cutting-edge sector. Plus, the technological spillovers will be enormous. Advances in robotics, autonomy, materials, propulsion necessary for asteroid mining. They'll inevitably benefit countless sectors back here on Earth. Advanced manufacturing, AI, environmental monitoring, sustainable energy, it's a powerful engine for innovation.
But there are significant weaknesses too, right?
Yeah.
And limitations.
Definitely. The economics, as we keep saying, are still incredibly uncertain. Despite the optimism, the sheer development and operational costs are staggering. Timelines are incredibly long, unpredictable. Market responses to a hypothetical flood of space materials, largely unknown, potentially destabilizing. Many asteroid-to-Earth metal business models, under rigorous scrutiny, just might not be viable, especially anytime soon.
And the legal side is still shaky.
It is that ongoing legal ambiguity and fragmentation. National laws create a patchwork, not a unified global framework. The lack of multilateral enforcement raises substantial geopolitical risks, especially as more players gain the capability to go out there. That legal gray area, if not tackled through international dialogue, could easily lead to disputes, competition, instability in what should be a cooperative frontier.
And finally, the dangers, the ethical concerns.
We absolutely cannot ignore those. There's the real risk of resource imperialism. Without robust, equitable international rules, the benefits could just flow disproportionately to already powerful states or corporations, worsening global inequalities. A historical pattern we have to consciously avoid repeating.
And the environmental ethics in space itself.
Crucial. This raises that vital question. What's our responsibility to these celestial bodies? We need to proactively develop clear, universal environmental ethics for operating out there. Rigorous norms to prevent harmful alteration of asteroids, planetary protection from contamination, mitigating orbital debris. These aren't just engineering problems, they're profound ethical and moral challenges needing attention now.
Right.
And finally, that market destabilization risk.
Right.
While often sensationalized, it is a legitimate concern. If truly vast amounts of precious metals somehow did become available on Earth, commodity markets could indeed collapse, with wide-ranging, unpredictable economic consequences globally. It's a very delicate balance. Ambition, ethics, economic reality. #outro.
Wow. Okay. What an extraordinary journey we've taken today. We've really covered a lot of ground, haven't we? From those vivid sci-fi dreams that first sparked the whole idea to the very concrete, innovative legal frameworks being built right now. We've explored that deep psychological pull towards the cosmic frontier, weighted against the harsh economic realities, and shifted focus from, headlines about asteroid gold to the pragmatic, maybe more crucial extraction of water in space.
And the story, as you can tell, is absolutely far from over. What experts are watching right now is incredibly dynamic, constantly changing. Scientific agencies, NASA, JAXA, ESA, They're hyper-focused on analyzing the data pouring in from OSIRIS-REx, Hayabusa 2, and eagerly awaiting results from Psyche, really trying to understand composition viability. Meanwhile, space resource startups and their investors, they're rapidly shifting strategies, moving decisively towards more pragmatic business models in space services, water, and propellant production, rather than immediate metal return to Earth. And critically, legal scholars, policymakers, they're intensely analyzing how national laws mesh or clash with the Outer Space Treaty, pushing hard for multilateral mechanisms, benefit distribution, liability management, conflict prevention. This raises that important question again. It's such a dynamic field, and the answers are still being written, often in real time, by engineers, lawyers, entrepreneurs.
So what does this all mean for you listening? Asteroid mining, it's like a profound mirror, isn't it? Reflecting our species' unique blend of technical brilliance and, well, mercantile ambition, our boundless scientific curiosity and our persistent political tensions.
Well said.
It's true, transformative impact, it might come less from shipping platinum back to Earth to enrich a few, and far more from enabling a completely new cislunar economy. Think vital fuel depots in orbit, building large structures from space materials, weaving this robust logistical fabric that finally lets humanity travel farther and stay longer in space than ever before. So, will the next decades really see the first profitable applications be those foundational in-space utilities, not the speculative bullion? And maybe the biggest question, how will we, as a global society, ensure we consciously avoid repeating the extractive injustices that have marked our history here on Earth as we venture into this unparalleled new cosmic frontier?
Yeah.
It's a future we are all, whether we realize it or not, actively helping to shape with every policy decision, every scientific breakthrough, every dollar invested. So maybe the final thought is, what kind of future do you want to see unfold in space?